Hello children, good morning. How are you? Almighty is our Savior. I hope you are all well safe. I welcome you for the online class. Today I am going to take the class for 7th standard geography. Since it is the first class for 7th standard geography, we will discuss regarding this subject and then we will move to the lesson. First we will see geography. Geography means study of earth. Study of earth. Actually it is derived from two Greek words. Geo means the earth. Graph means to write. Okay children, next we will see importance of geography. That means we get essential knowledge about world, place, development, etc. Next we will see benefits of geography. That means we can understand of our world, then weather and climate changing, water resources and natural resources, and also environment. Now we will see the father of world geography. Can you say father of world geography? Okay. See this picture. Eratosthenes. See this picture, Eratosthenes, father of world geography, born on 276, died 194 BC. Eratosthenes of Cyrene. Cyrene, it is a place. At present we call it as Libya in North Africa. Eratosthenes of Cyrene was a polymath, mathematician, a poet, astronomer, geographer and music theorist. At his old age he became blind and he has committed suicide by voluntary starvation. Actually he was a man of learning, becoming a librarian at the Library of Alexandria of Egypt. He introduced an efficient method of identifying prime numbers. He introduced the prime numbers. He invented latitude, longitude, calendar that had leap years. He calculated the distance from the earth to the sun. Okay children, now we will go to father of Indian geography. See this picture. James Renal. James Renal was the father of Indian geography, born on 3rd December 1742, died 29th March 1830. James Renal was an English geographer, historian and a pioneer of oceanography. Oceanography means the study of ocean. Actually, Renal produced the first accurate maps of Bengal as well as India's outline maps. His maps were well used in the 19th century. So Robert Clive asked him to do so because to control the large territory. Okay children, now we will see the first lesson, interior of the earth. Actually, interior means inside. Inside. What happens inside, that we are going to study. Before that, we will see the surface of the earth. See this picture? Surface of the earth. On the surface of the earth, you can see lofty mountains, valleys, plateaus, plains, human beings, buildings, plants and animals. Actually it is present on the surface of the earth. Earth, if we take earth actually it is our homeland. Okay, now we will see the first lesson, interior of the earth. Interior means inside. Before that, we will see the surface of the earth. On the surface, we can see mountains, valleys, plateaus, plains, human beings, buildings, plants and animals. So, it is present on the surface of the earth. Earth is the only planet where we can survive. It is the third planet from the sun. It is the fifth planet in the solar system. It is a dynamic planet which undergoes a lot of changes both inside and outside. Actually, Earth is called as said to be blue planet. Why is it so? Because 71% of the earth is covered by water. So, the earth is said to be or otherwise called as blue planet. Now, what are the things we are going to learn in this lesson? First, we will see now the learning objectives. First, interior of the earth. Second one, role of plates. Third one, earthquakes. And volcanoes. These are the things today we are going to see. First, we will see the interior of the earth. First, we will see interior of the earth. Actually, the earth is compared to an apple, egg, or an onion. See this picture. See this picture, onion. If we cut the onion, we get or we can see the view, the layers. It is arranged one after another. Cross section of the onion. See the layers. On the basis of the study of earthquake waves, the spherical earth is to be found 3 concentric layers. They are first one, crust. Second one, mantle. Third one, core. So these are the 3 concentric layers. First one is crust, second one mantle, the third one is core. Okay children, see this picture, interior of earth. Already I told 3 concentric layer, crust, mantle, that is core. That is crust, mantle, inside the center, that is core present. Now we will see first layer, crust. Here also in this picture, crust. Second layer is mantle, and the interior, that is inner core. See the same here also the structure, crust, mantle, inside inner core. The same here also see the layers elaborately. First layer crust, second one mantle, the center inside, that is core is present. Now we will see the crust, first layer, the crust. Actually, crust, it is the outermost layer of the earth. It is the outermost layer. It is composed by three types of rocks. See this picture: igneous, sedimentary and metamorphic rocks. The crust is composed by three types of rocks: igneous rocks, sedimentary rocks and metamorphic rocks. The crust, it consists of numerous plates. These plates, the shifting of these plates result in the formation of continents, and its thickness is 35 km on the continental mass and only 5 km on the oceanic floors. Despite greater thickness, the continental crust is less than the oceanic crust because it is made up of both light and dense rock. The oceanic crust is composed of basalt rocks. The crust comprises into two distinct parts. One is the upper crust and the second one is the lower crust. The upper crust consists of granite and forms continents. It consists of minerals like silica and alumina. Collectively it is called as Cr. Its density is 2.7 gram per centimeter cube. Now we come to the lower crust. The lower crust is composed of basalt rock, forms oceanic crust. It consists of minerals like silica and magnesium. Its density is 3 gram per centimeter cube. Now just I write down the points. You use your rough note and pen. Just note down this. Very simple. It consists of 2 or 3 words only. Go through once again. Outermost layer, three types of rocks. Third one, number of plates. Resulting in the formation of continents. Thickness, (35 km) continental. Only 5 km ocean floors. And then it is divided into two. One is crust, second one is lower crust, sixth one its density. Density is 2.7 gram centimeter cube. Minerals like silica and alumina. It is collectively called referred as CR. Outermost layer, 3 types of rocks, number of plates resulting in the formation of continents, its thickness 35 km on the continental crust, only 5 km on the ocean floors. It is divided into 2 parts, upper crust and lower crust. Density is 2.7 grams centimeter cube. It consists of the minerals like silica and alumina, referred as CR. Upper part we have seen, upper crust that is. Next we will see the lower crust. This lower crust consists of the basalt rocks, forms oceanic. It contains the minerals. It is silica, and magnesium. Collectively referred as seam. Lower crust, it consists of the minerals silica and magnesium. It is referred as seam. Its density is 3 gram per centimeter cube. Lower crust, it consists of minerals silica and magnesium, referred as seam. Its density is 3 gram centimeter cube. This Sial and Sima together form Earth's crust. Since Sial is lesser than the Sima, the continents are said to be floating on a sea of denser Sima. The second layer, mantle. Now we will see about the mantle. See this picture. Second layer, this mantle. Now we are going to see about this mantle. Actually, the mantle forms the main mass of the earth. It forms the main mass of the earth, and also it is the middle layer, or otherwise second layer, or otherwise we can say it is present in between crust and core. It is separated by a boundary. The mantle is separated by a boundary called Mohrowitz discontinuity from the crust. Next one we can see the thickness is about 2900 kilometer, and also it is divided into 2 parts, that is upper mantle and lower mantle. The upper mantle, the density is 3.4 to 4.4 gram per centimeter cube. It extends down 700 kilometer. Next, the lower mantle. The lower mantle, its density is 4.4 to 5.5 gram centimeter cube. It extends from 700 to 2000 kilometer. Now say this, the mantle forms the main mass of the earth. It is the middle layer. It is present next to the crust, or in between the crust and core. Mantle is present, and also it is separated by a boundary called Mohrowitz discontinuity. Its thickness is about 2900 kilometer, and it is divided into two parts, that is upper mantle and lower mantle. The upper mantle density is 3.4 to 4.4 gram centimeter cube, extends down 700 kilometer. Next, the lower mantle density 4.4 to 5.5 gram centimeter cube, extends from 700 to 2900 kilometer. Actually, the mantle is partly molten layer. Its temperature is reaching 4000 degrees Celsius. Okay children, that's all about this mantle. We will see the next layer. Okay, next one we will see the core. Actually, it is the innermost layer of the Earth's crust. See that? Innermost layer, and otherwise it is also known as barysphere. It is separated by a boundary called Weizsäcker-Gutenberg discontinuity. From the mantle it was separated, and it is divided into two parts, that is outer core and inner core. First we will see the outer core. It is rich in iron. It is in liquid state. It extends from 2900 to 5150 kilometer. Next we will see the inner core. Second one is inner core. It is composed of nickel and ferrous. Knife, it is in solid state. It extends from 5150 kilometer to 6370 kilometer. The central core has high temperature and pressure. Once again we will see this core. It is the innermost layer, otherwise it is called as barysphere. It is separated by a boundary called Weizsäcker-Gutenberg discontinuity. It is separated from the mantle. Next, it is divided into two parts, that is outer core and inner core. The outer core rich in iron, and also it is in liquid state. It extends to 2900 to 5150 kilometer. Next, inner core composed of nickel and iron, that is ferrous. Knife, it is in solid state. The central core has high temperature and pressure. It extends from 5150 kilometer to 6370 kilometer. Its density is 13 gram per centimeter cube. That's all. Now we have seen about crust, mantle and core. Next we will see the role of plates. Okay children, now we will see the role of plates. So this role of plates, earth movements. How the earth movement takes place, we will see that. Actually, the lithosphere is broken into numerous plates. This is known as, or otherwise termed as, that is lithospheric plates. Broken into number of plates is called, or otherwise known as, said to be lithospheric plates. This each plate, oceanic or continental plate, moves independently over the asthenosphere. Actually, asthenosphere is nothing but a part of the mantle. We will see the movement of the lithospheric plates, that is called as or termed as tectonic movement. Now these plates moves. The plates of the lithospheric plates move. This movement is called as tectonic movement. Tectonic movement means nothing but the movement of the Earth's lithospheric plates. That is called or termed as tectonic movement. Next we will see that the energy required for this movement, that is produced by the internal heat of the earth. They need energy to move this. It is produced from the internal of the earth. so that these plates move in different directions at different speed. Due to this energy, they move different direction at different speed. Once again, say this. Lithosphere, it's broken into a number of plates known as lithospheric plates. The oceanic and continental moves independently over the asthenosphere. Asthenosphere is the part of the mantle that flows and moves the plates of the earth. The movement of lithospheric plate is known as tectonic movement. For this, they need energy. It is produced from the internal of the earth. The energy required is produced by internal heat of the earth. These plates move in different direction at different places. At places, they move far away from each other, creating wide rift. At some places, they come closer and collide each other. When the oceanic plate collide with continental plate, since it is greater dense, when the greater dense force to the continental plate, it goes below the continental plate. As a result of pressure from above, the rocks heats up and melt. The molten rock rise once again, forming volcanic mountains along the continental edge. Alternatively, a trench may be formed between the two plates. And also, when the two plates converge without any force, it forms folds. Great ranges like Himalayas have been formed in this way. See here, as a result of pressure from the above, the rocks heats up and melts. Molten rocks rise, forming volcanic mountains along the continental edge. Alternatively, a trench may be formed between the two plates. At some places, the two plates converge, form folds. This result, the great ranges like Himalayas have been formed in this way. These movements of the plates causes changes on the earth surface. The earth movement is divided into two parts on the basis of the force. There are two types of forces, that is endogenic force and exogenic force. The endogenic force which act inside the earth. For example, it causes sudden movement like earthquake and volcanoes. It causes mass destruction on the surface of the earth. Next one is exogenic. This exogenic forces that works on the surface of the earth. It also causes light or lightly destruction. See the picture. Now I will show two types of forces, endogenic force and exogenic force. Sudden movement like earthquake and volcano. See this picture. Example, volcano. Exogenic, it causes a slight destruction, that is maybe water, waves, ice or wind. Example, ice. See the picture I have given. Two types of forces, endogenic, exogenic. Interior of the earth cause sudden movement, earthquake or volcano, which acts on the outer surface of the earth, that is exogenic. Example, ice, wind, waves. These are the examples. The last one is earthquakes and volcanoes. This we will see in the next class. Before that, just once we will recollect the interior of the earth, 3 concentric layers. The first one is crust, mantle, core. Crust, outer surface of the earth. Mantle, that is the next layer of the crust. It lies in between the crust and core. It is separated by a boundary, that is Mohorovicic discontinuity. And then core, the core is separated by Weizsäcker-Gutenberg discontinuity. This is the innermost layer, and also the core plays an important role. It is responsible for magnetic field. This magnetic field it protects us from the harmful sun's rays. And also we have seen the 2 types of forces, endogenic and exogenic. Endogenic, that is inside, it causes interior of the earth. Example, earthquake, volcanoes. Next one is exogenic, outer surface of the earth. It causes waves, wind, ice, like that. Examples. Okay children, just go through this and we will meet in the next class. Okay children, thank you.